Because
Okay.
do not go into running the engine without checking everything. Like for example, check your tank to the L joint. That is the most important thing before you crank the engine. Okay,
Yes.
make
Yes.
sure that there are no leaks there.
Okay.
Next, what else?
Yeah. Yeah. So the next, this is phase one. So after we've made sure that there is no leak happening at the junction between this L joint and the engine, uh, we have to.
Are you making a note of this somewhere? Is somebody making minutes of the meeting?
Yes. Yes. Yes.
Okay, fine.
Yeah. So these scavenge lines will extend to the oil, to the scavenge pump, like I told you. So these pipes will be first made on CAD, and CAD model will be made, and then they'll be manufactured and then welded.
Where are you showing me? What are you showing me?
You see these
Which
two,
line item?
yeah, outlets of these two scavenge lines that are coming out of the pan on the right side.
Uh,
Yeah.
Share your
So
screen. Bring it, pop it up. Whatever you're telling me, show it on your screen.
wait, it's this is in my phone. Can you look at the picture?
Dude, the fuck is wrong with you? You're presenting. It's your responsibility to make sure everything is at one stage.
Okay. 1 second.
Bring it up. Bring it up on your screen.
Yeah, 1 second. I got it. Yeah. Can you see it now? Hello.
Here, second.
Yeah.
Yeah.
This
Tell me.
these two extensions
Yeah.
go into the scavenge pump, and just like the L joint, they have two O-rings on the lip.
Okay.
So these have to be manufactured.
So, okay.
Uh, yeah. What else? Yeah. Yeah. That's it. That's the plan. So these have to be made on CAD first, and then these have to be welded.
Okay, dude. Approved. Go.
Okay. Fine.
Anything else?
No, nothing else.
Yeah, just do the engineering right.
What?
Just do the engineering right. Okay.
Okay. Okay. Okay.
Think about everything
We've
and then.
made we've made the MOM of the meeting. We'll send it to your email as well as our group.
What?
We've made the MOM, minutes of the meeting.
Okay, sure. Great.
We, yeah, we'll share it with you.
All right. Awesome. Is that it? Okay, good.
Yeah,
Thanks.
yeah, that's it. That's it.
Thanks.
Yeah,
Bye.
one more thing. Shubham, one more thing.
Yeah.
Hello.
Go
Yeah.
ahead.
About the intake manifold, we are trying to look for a 3D printing sponsor.
Uh-huh.
Okay, so we've approached 4 or 5 companies, um,
Uh-huh.
and it turns out that no company is agreeing.
Why?
One company actually agreed first, and then when they found out that our volume is a lot, and they specialize. It's called Intech DMLS. The company, it's in Pina. They do SLS of metal.
Yeah, they cannot print for
So
you.
yeah, but they told us that they got a new 3D printer that can print plastic also. But later
Okay.
they backed off.
Okay.
So so I we're still trying to look for 3D printing companies. I want to know if we can approach Ankit Sahu this year.
I don't know. Like what happened last year?
See, last year it was like an up and down situation. But just before manufacturing, he was like, "This is my last thing with Ashra, and I won't do it from next year." And but after it got manufactured, he actually came to the workshop and talked to us properly.
Okay.
So we don't really know how he feels about this whole thing right now. So
I don't know. I don't talk about that sort of him. Actually, hell, I haven't talked to him in around 6 7 months. So
uh, I didn't get you. Could you repeat?
I haven't talked to him in the last 6 7 months. So I do not know what he feels or whatever it is. It's your job to
Okay.
go and approach.
Okay, fine. Should I be sending a mail to him?
I don't know. How have you
Okay.
guys been communicating with him?
It was mainly through phone on phone. Karan contacted
Yeah.
him on phone.
Yeah. And my question is, what happened with the last year's intake?
It is working pretty well. There have been no issues with it
Okay. Then why do you need to change intake?
because this car is getting preserved, and that is
Like
one
that,
reason.
are you designing something new?
Yeah, I'm designing a new intake. It is almost done.
Why?
Yeah.
Why? Why?
There are many reasons.
You just
One
said
is
it's pretty good. If it's pretty good, means there should be no reason for you to change it.
no. I mean, the working is pretty fine. As in there, we faced no issues on the car. It hasn't I mean, it hasn't broken down due to a backfire or something. I meant that way. But
Okay. And what is
this there are many issues like uh, the inner part is very rough, so you have to make sure so the boundary layers get affected because of this roughness. So if you zoom into the inner structure, you'll have basically have hills and valleys. So the boundary layer gets arranged according to those hills and valleys, which hills and valleys. So because of which the pressure loss increases, total pressure loss increases, and because it's a
and
naturally aspirated intake, and this is one thing.
go
And
ahead.
Karan's intake had the design aim of as such of his intake was to get even distribution. Okay,
Uh-huh.
and it was not to increase volumetric efficiency. So
Uh-huh.
we're trying to improve the volumetric efficiency this year.
Let me ask you a few
But
questions.
yeah, we've
Uh,
discussed this in the last hangouts.
yeah, I don't care. I'm just asking a few questions. Now,
Yeah.
this is in general for everything that every batch in Ashwa does. Uh, Let me pick at you first. So you're
Okay.
telling me that there are hills and valleys that will affect the performance of the engine, right?
Are you going to
Where do
ask
you
by how
currently?
much?
Yes.
Uh, See, the difference is I can tell you, uh, 2015's intake. Okay,
Uh-huh.
it showed a total pressure loss of about 15 millibar at a particular volume flow rate. Okay, and this year's intake shows double of it, 32 millibar.
Okay.
So that is a lot.
My question is, were both of them put on a dyno?
As in compare, put
Yeah.
what both the intakes.
Were they put on a dyno? Were the engines put on a dyno? Were they tested?
But we don't have engine dynos in college or in Bangalore.
Vehicle dyno.
Yeah, we don't have it.
What are you telling me?
Yeah, we don't have one in the college.
No, nobody's asking you to. Dude, we've gone and done dyno testing in Bangalore. Okay. Don't tell me you don't have access to it.
It's a chassis dyno. It's not an engine dyno. RD has race dynamics has a chassis
That's what I
dyno.
said. Vehicle dyno. It's a chassis dyno. So, what does a chassis dyno do?
It's a vehicle dyno. I mean inertial dyno. The
Yeah,
whole
so
car
what
is
does
on it. Yeah, the whole car goes on the dyno.
not the full car goes onto it? It's only the driving wheels go onto it for mounting the non-driving wheels. So, yeah, uh, what's wrong in testing on that?
See, so are you asking us to test these two intakes, the 2015 intake and the 2017 intake?
My
Or
question is, you are telling me that one showed 15 millibar, one
yeah,
showed 32 millibar.
yeah,
If
yeah,
you're
yeah.
saying that two of
So one,
them are, one out of the two is comparatively better, what is the
yeah.
data that you have to tell me that it's better?
This is not based on analysis. This is based on a flow bench test that was done at Man.
Both of them?
This is a validation thing that we did. This 32 millibar and 15 millibar, it was put on a flow bench testing machine at Man in Kenya. So
Okay.
the machine sucked air at a particular flow rate, which is calculated using a formula, and
Mm-hmm.
pressure. There were pressure sensors at the inlet and at the outlet. So three runners were closed, and air was let in through one of the runners, and the
Okay.
pressure loss at the outlet, but the pressure difference between the inlet and the outlet was taken.
Okay. It's 32 millibar.
Yeah.
So it was a suction that was being done, right?
What?
Okay. 32 millibar drop. Now, my next question is, how does that affect the performance of the engine?
Uh, See, I,
That
oh,
32 millibar will be at a
I,
specific flow
yeah, I
rate,
can tell
right?
you.
Not
Yeah,
at every flow rate.
yeah. 32 millibar is a loss. Yeah,
At a specific flow rate or at
at
every
a
flow
specific
rate?
flow rate, obviously. At a specific flow rate. Yeah.
Yeah, because that would be your zone of constructive or destructive interference wherever you lie.
Yeah, that is a real case scenario, but this is just constant flow.
Yeah, constant flow. My question is, did you do a constant flow rate at every RPM? That means you have 1 point data. You do not have a spread. So why
Yes,
did you go to
and
man and Hubble? What was the point of it?
the point was that to see, we cannot do. We're trying to do this acoustic analysis of the intake. Okay, a transient
To,
analysis
to,
of the intake.
to, to that, to that, when you got actual flow bench, why can't you test all your operating points? It's just additional time because setup time is what is the most expensive thing, right?
Yeah.
Why can't you run a speed starting from 1000 RPM to 10,000 RPM and then come back to PC and say that, okay, this is my flow rate and this is my pressure drop. You know how that helps you?
I'm trying to tell that I told we discussed pressure waves on the last hangouts, right? So
Uh-huh.
we tried to do transient analysis of the intake, and
Uh-huh.
see we don't have the tools, we don't have the
What
simulation
to,
knowledge to actually carry out that kind of simulation. We
fine, fine, fine.
tried,
I'm not even talking about simulation knowledge. At
yeah.
least if you were on a test bench and you ran the entire spread,
Mm.
when it comes to tuning, you would know where your engine would lie. Even better would be if you had done the intake with the cylinder head.
You're saying the test with the cylinder head, intake
Yeah,
with the cylinder head,
yeah, why not? That's the correct way of doing it.
but uh, how do we do this? See, valves
Automatic
have to be
valve.
there. There have to be two valves which have to open and close at the right time. Okay,
Uh-huh.
and then there
You're
has to
doing a
be
flow rate.
the pistons have to go up properly and it should be sealed.
So,
How do we
so
get this set up?
you are doing flow rate of you're doing flow rate of nozzles, right?
Yeah, yeah.
Actually, so you just remove the intake valves, okay, and you run the specific flow rate, okay, which means when I say flow rate, when you are at 1000 RPM at mean position of the piston, what is the speed at which air will be moving in? Okay? Basic calculation. How much are you actually supposed to pull? Let's say you have a 100 cc that you need to pull into the cylinder, okay, and you know the rate at which your piston is going to move at its mean position, you know the flow rate.
See, the flow rate will be purely based on the suction uh,
Yes.
that the engine is
So
generating.
the flow rate will be should be purely
So
based on
this,
the demand set by the engine.
yes,
Okay?
exactly. So yeah, so this vacuum pressure, to get this vacuum pressure correct, you will have to have a
Yeah.
sensor inside the setup, correct? To plot this vacuum pressure at 1000 RPM.
Yeah.
So,
No, 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 no. Dude. Okay. If I were to take, okay, in a naturally aspirated engine, what
yeah,
is the, if I remove the cylinder head, that is the best amount of air that I can have inside, right? At 1 bar. At any point of
yeah,
time, if I have a cylinder head and intake and everything, the pressure inside the cylinder at suction is going to be less than 1 bar, right?
yeah, at BDC, yes.
At BDC or TDC.
TDC, yeah, 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 correct.
Okay. So that being said, if it's going to be at 1 bar, that is the actual demand set by the engine, right? Right?
Uh, 1 bar is, you're saying 1 bar is the demand set by engine?
Yeah, because you do not
No,
have a forced induction system.
no, see, it should be ideally vacuum, no, for the air to come in. So it should be evacuated, the cylinder chamber.
Okay, if it's vacuum, then what is the mass flow rate?
So yeah, once air starts coming inside the chamber and the piston is going up, this vacuum pressure keeps on changing, and air stops coming in whenever this pressure inside the cylinder becomes equal to the pressure inside the manifold.
Dude, there is a vacuum pressure because there's a freaking cylinder head. If there
Yes,
wasn't a cylinder head, what would be the pressure?
1 bar.
So that's your demand, right?
Yeah.
Everything above the cylinder head, intake, throttle body, everything, there are restrictions to your system,
Yeah,
right?
yeah,
So
yeah.
can you calculate based on engine speed what will be the mass flow rate at 1 bar?
Theoretically,
Yes, that theoretically is actually a demand. Okay, that is the ideal scenario. Now, once you put that demand as suction on a flow bench, then everything above your cylinder head, your intake, your throttle, everything gives you the losses that are happening for the system. You understand that?
yeah, I understand that. But see, in a real case scenario, okay, you're saying purely flow wise, okay. Now, in a real case scenario, you will have valves closing and opening. So the
Yes.
the acoustic waves will carry the air up and down. So that cannot be done on a flow bench. Even if you find
Okay,
the
but wait
even
a
if you
second.
find the
How much of an
even if
effect
you,
does that have?
it has it has quite an effect. On Ricardo, we
Give
have
me
learned that,
give me
yeah.
percentage.
Okay, it varies from zero point 0.8 atm to 1.2 bar atm.
You so that 1.2 bar is at point of constructive
So
interference, right?
yes,
And what is it overall range?
overall range is from zero point 0.8 atm to 1.2 atm.
Okay, let me ask you this. What is the distribution of it from point 8 to point 9, point 9 to point 1, point 9 to 1, 1 to 1.1, and 1.1 to 1.2? What duration of operation time are you in a specific pressure drop zone?
You're saying for how much time this 1.2 bar is going to be there?
Yeah, at what RPM? How so? Like what RPM range is 1.2 bar going to be there?
Yeah, that will depend on what RPM the intake is tuned for. So at that RPM, whenever the intake valve opens, for a very small moment, there'll be that duration. I can't tell the duration.
So my question is this: Is your what is the mean pressure across which your engine will run? Suction pressure.
I don't know the mean pressure. Vacuum pressure, you mean?
Yeah, what is your point 0.8 bar, point 0.9 bar? What's your mean? What's your average? If I were to take the area under the curve, okay,
Okay.
and then find out an average, what would it be?
What is the graph plot between pressure and area, or pressure versus crank degrees?
Pressure
Hello.
versus RPM, dude. Pressure versus RPM.
Pressure versus RPM. I can get the plot from Ricardo, but the areas will the area give?
So can I?
Yeah, it has
Okay.
to be pressure versus crank degrees, and the area will give something that is proportional to volumetric efficiency. Correct. So you want the plot of pressure versus crank degrees, right?
Okay, what I want to know is at every RPM, what is the volumetric efficiency that you are getting? Okay,
Yeah.
at
Okay.
every 1,000 degrees, and then tell me what is the average volumetric efficiency of the engine throughout the operation phase. You know how to find
Okay.
average.
Yeah, I know how to find average.
Okay, so do that, and then what your average volumetric efficiency is going to be. That is your that will determine your suction pressure that you'll have an average. So you should be designing for that. Because that one-off scenario where you get the best 1.2 bar constructive interference, it also has a negative effect where you get a destructive interference where your engine torque and power will suddenly drop.
So you're
You
saying this
understand?
whole, yeah, so I understand. So this whole thing has to be done not on the computer. It has to be done in real. You mean taking the valves off
Yeah.
and getting the
Yeah.
getting pressure.
Yes.
How much do you think this will cost? It will cost a lot, right?
Am
Because
I in India?
pressure sensors and
Oh, wait, wait. You have a flow bench at Man and Hummel, right?
yeah. So, but you
They don't
said
have a pressure sensor.
they have pressure sensors. Yes.
You can't go and measure it there.
So no, can you tell me how to make the cylinder head? As in, we have to take the engine. You mean?
Okay, when you go to Man and Hummel, you mount your cylinder head, you mount your intake, and you will give a specific suction rate, flow rate, right, on the machine.
Yeah.
Calculate that number theoretically and give it to him as an input for the experiment.
Wait. So we have to take the cylinder head, right? Cylinder
Yeah.
head, correct. So so the setup is such that the setup sends in air, okay, at a particular volume flow rate, and
Mm-hmm.
what
Sends
about
in or
what
pulls in.
it pulls in, but what about the other end? If it's going inside the cylinder head, it
Uh-huh.
cannot. From where will the air come out?
Take the intake valve off.
Yeah, intake valve is off, okay, and all the air goes inside the cylinder head.
Yeah, and then where does the air go? Back into the machine?
Okay, fine. So pistons have to be outside.
Shubham, we actually did a flow bench back in 2014. It is just of the cylinder head without the intake. Will that help?
Yeah, that does help. That gives you no that will help you in optimizing the cylinder head, not optimizing your intake system.
We have the pressure drop across the cylinder head.
Uh-huh.
So the rest
Good.
can be done. So the only thing that's remaining is the pressure drop across the intake. I'm
Intake
only
and the cylinder head system. Okay. You always need to understand this. When you have the hardware, it's always better to understand system interactions. All right.
yes,
So when you have that, it's better to integrate systems together rather than interpolate or extrapolate data.
correct.
Okay. To do that, that actually gives you the pressure drop across the system.
Okay, instead of doing all this, why can't we? So in the next intake manifold we make, we can make uh, two say holes for or ports for the mass flow rate or pressure sensor to sit, and then the
You can't put a mass flow rate sensor. You don't have it. You don't get the size that you need.
okay
Move on.
the pressure sensor
Nowhere in the world will you get it. Pressure sensor, you already have a MAP, manifold air pressure sensor.
that is in the plenum, no?
Yeah, where do you want to put it? In the cylinder head?
End of the runners, yeah.
How do you access it?
End of the runners in on the intake itself, not inside the head.
Yeah.
Just where
And how does that help?
that can be put behind the injectors or something.
And how does that help?
So you can get your vacuum pressure, no? Whatever is getting, whatever vacuum pressure you're making at the cylinder valve, at the valves, that will be,
And why would I do it on a live running engine?
you can get a proper curve
On a
on a
vehicle?
particular RPM. It'll
Why will I do it? Why will I do it on a vehicle? Why not on a test bed?
because you'll get acoustic interaction values as well.
How do you know that they're acoustic?
Because it's on an engine, on a running engine. We'll have the pressure values correctly.
Okay. So you're telling me you're gonna tap mass, air pressure sensor on each runner,
Yeah,
right?
yeah. Pressure sensor.
Well, Honda has one something like that. Um, okay, and then you will wait for how much more time to implement that data?
See, this cannot be done on the intake we have now. It has to be done on our intake.
Mm-hmm. Okay. So do one thing, chalk out a plan. What exactly you're gonna do
Okay.
with a timeline,
Or what we can
like
do
a
is,
Gantt chart.
can
Mm-hmm.
we try?
Nope, nope. I need a plan.
Okay, okay.
I need a plan. Timeline, steps that you're gonna take, send it over.
Study and send it over.
Okay.
Take that and send it over. Anything else?
Uh,
Shubham, I have a question.
Yeah.
So this is a new issue that has come up recently. Before this, we never faced this issue. I'm talking
Mm-hmm.
from 2014. So
Mm-hmm.
what happens is we run the car. The car is running fine. We run it for a while. Then
Mm-hmm.
suddenly the car stops. Okay, on its own. So we diagnosed the issue. The issue was fuel pump. The fuel pump does not
Okay.
build pressure. So beginning we thought it might be a fuel issue, as in there's lesser fuel in the tank. So then we used to pour more petrol, and then again the pump used
Mm-hmm.
to build pressure, and we used to run the car. But then it also has happened that there was petrol in the tank, and yet the pump stopped running.
Okay.
Stopped running as in the pump runs, but it makes a very low intensity noise uh, rather than the high intensity noise, and it does not build 3 bar. This we see on a pressure gauge at the rail. So it is not able to build fuel pressure. So what we usually do is we wait for a while, and the pump
Mm-hmm.
again starts. Uh,
Okay.
you
My
also,
question is,
yeah,
have you checked out the pump? Have you removed it
removed it.
and checked whether it's have you removed the pump and checked whether it's clean or not?
Yeah. I haven't. I haven't finished. So we also noticed that the fuel tank gets very hot because of the close vicinity to exhaust. So we thought the pump is faulty and it does
Mm.
not function at higher temperatures. So what we did was remove the pump. We connected the pump outlet. We put a hose back into the tank itself, and we ran the
Uh-huh.
pump. We
Okay.
ran it continuously for like 20 minutes, and there was no change in flow rate. I mean, visible. I'm talking. We didn't measure it.
Okay.
There was no visible change in flow rate. We then we took the pump to Continental. Continental makes fuel system units for commercial vehicles. So we took the
I
pump
know.
to test. Yeah.
Okay.
So what they did is they put it in their testing apparatus. They
Uh-huh.
so I told them this. They said obviously it is not running against any pressure, so the pump should run fine. So I said okay, fine. They put in their apparatus. They ran it at 4 bar and 3 bar. They changed the
Okay.
pressure externally. 4 bar and
Okay.
3 bar, and they ran it 15 minutes in each setup.
Okay.
Uh, and there was no issue with the pump. This is a Bosch pump,
There's
and
something wrong with it. Why are you taking Bosch pump to Continental?
they said it's fine. I mean, the Vamsi is there in Continental. Uh,
Okay. Fine.
he was like, it's okay, get it. We just wanted to test the pump. So
Okay.
and they also use this pump. Like they have the pump in their this thing. I don't know. They said they had the same pump. They
Yeah,
showed
it's
they
the
showed it.
standard pump that almost every company uses for fuel pickup.
Yeah. So also before I took this pump to Continental, I put a CBR 250 ka pump. It was building 3 bar, but the
Uh-huh.
problem was it had a lesser flow rate, so we couldn't run with the same pump.
Okay.
Anyway, so the problem was the fuel tank was getting hot, and we thought the pump is getting hot because of that. But then
So if the fuel tank is getting hot, then how does it affect the pump?
because the pump assembly is metal, so I thought it is conducting heat through the flange and then to the pump.
So you don't have a heat reflector on your fuel tank?
It's there, it's there. We have chop suey and aluminum tape, but still it gets hot. But then they said no, these pumps have very high temperature
Yeah.
resistance.
Yeah,
They're
you
very
do.
robust. Yeah, so temperature is not the issue. So what they,
Yeah.
so what do you think the issue can be? Because if you continuously run
Mm,
the car, nothing happens. It stops. We pour in petrol, or if we wait for it to cool down, it'll start.
somewhere in your line there's a blockage.
Line. No, the line is clean. We checked the lines. The injectors are
Then
clean, the rail is clean, and the whole hose is clean. The fuel hose.
and how do you maintain the pressure in the system?
There's a pressure regulator in the pump assembly.
Are you sure?
Yeah.
How big is the pump?
How big is the pump? Matlab, it is flange is 110 mm dia. The length is around
Uh-huh.
180 mm. The full,
Okay,
assembly. The
so
pump is smaller.
it's a pump assembly.
Assembly, yeah.
Okay. So my next question is it possible that you have a faulty electrical connection?
No,
How
because
do you know that?
that yeah, I'll tell you. So uh, we isolated the issue to the pump. So what we did was when the pump stopped on its own after a while, we directly connected the pump to an external battery, and the pump gave us same
Mm-hmm.
sound.
Then replace your pump. Then the pump is overheating somehow.
Okay. Okay. So at Continental, they also told us that there's something called a vapor lock. So what happens is, so the fuel tank becomes really hot. Okay, so you can't put your hand on the fuel tank; it gets that hot. So they said what might be happening is the petrol, after being sucked by the pump, it vaporizes.
Okay.
So basically, the pump is trying to suck
Uh, my,
vapor.
my question is this: how close is the pump to the exhaust?
It's close, like 100 mm maybe.
Oh, that's far. You've kept it around 1 inch.
Was your exhaust ceramic coated?
Nope.
No.
No.
Okay.
We didn't have that sort of money. It's just that the thermal reflector that we had was
Oh,
really good.
what did you use?
The thermal reflector that we had on the fuel tank,
Yeah, what did you
that was
use?
really
What
good.
thermal reflector?
It was an aluminum foil with a black mat in between, which was thick. It was a thermal acoustic mat. You can get it on Pegasus. What are you guys using?
We're using glass fiber and aluminum tape.
Who made this?
What?
Glass fiber and aluminum tape. Did you buy it or did you make it on your own?
No, no, glass fiber ka one layer and it is taped on to the fuel tank with aluminum tape. That's all.
Whose idea was this?
This was being done from like for past 2 years on components that were close to the exhaust. So even we did the same thing.
Smack all of you guys on your head. Go freaking spend money and buy that thermal acoustic mat.
Okay, so your fuel tank you never used to get that hot that you can't put your hand on it.
No, never.
Okay.
We've had the exhaust header
Hmm.
like within like the header like 3 inches from the top of the fuel pump assembly. Okay, and the exhaust pipe running like half an inch or an inch from the fuel tank.
No, no, ours is further than that.
Yeah, then you guys are not doing a good job of insulating it. If there's a vapor lock that's forming, then I'm sorry.
Okay, but do you think the pump is faulty because they ran it for half an hour at 3 bar and 4 bar, and they said the pump is not at fault. That's what they think. They said we think the pump is not faulty because these
No,
pumps
no,
are
no.
pretty
That's what they
robust.
know. That's what they know because they have tested it.
Yeah. So no,
Hypothesis.
yeah, but the thing is, this pump has been being used for a very long time also. So do you think this pump might be faulty?
Define a very long time. How many miles has it done? How many hours of running has it done?
I don't know. It's been used since 2014.
2014. How many hours would it have run?
I really cannot estimate that.
50 hours?
15 hours.
50, 50.
50. Yeah, probably more than 50 hours.
Yeah. These pumps are rated for like 2000, 3000, like thousands of hours of running. So there's nothing wrong with the pumps.
Okay.
Either you have not kept a clean environment and fucked it up.
No, no, no. It's clean. We always used a filter. Now, actually, I actually got another filter from. So for filter, we used to use muslin cloth. 2 layers of muslin cloth. When I went to Conti, I took a filter from them. So I removed the muslin cloth and I put a proper filter.
Okay, then it's something that you guys should go and solve in terms of thermal because these pumps are rated for like thousands and thousands of. Hear me out.
Hmm.
It's a very rare thing, like really, really rare thing for a fuel pump, a Bosch fuel pump, a low pressure fuel pump to fail.
Okay.
Once in the entire life cycle of let's say 10,000 vehicles.
Okay.
So a life cycle of one vehicle is around 150,000 miles of running.
Okay.
That is
Okay.
around 20,000 hours of running.
Okay.
It should do at least 20,000 hours. And I don't think
I don't. Yeah. I don't think we've done 20,000 hours.
if we were to ever do 20,000 hours, uh, yeah, I'd rather not do it.
Hello. Hello.
That's it.
I didn't hear you. What was the last part you said? I
Is
think
there anything else?
no. Before that,
Hmm.
after 20,000 hours, did you say anything?
Yeah, after 20, if you actually were to have a car which were driven for 20,000 hours, I don't know what would happen to the people and the car.
Okay. But you think it's not a pump issue?
I don't think it's a pump issue.
Okay.
It's an engineering issue. Okay, I understand this, guys. Whatever components that you get from these tier ones, they are way overrated for your application. Okay. First, look at where you might have screwed up. Okay.
Hmm.
If you don't find anywhere while doing a root cause, then you go into asking if the component might be wrong.
Okay. So this problem was not there since 2014 because the setup was almost the same. Basically, the distance between fuel tank and exhaust was pretty much what it is right now. But the only difference was the exhaust was ceramic coated, and the fuel tank was never as hot as how it is now. Hello.
Hello.
Yeah.
Understood. Okay. You know how to solve it?
Yeah.
Go
Yeah.
and solve it. Okay.
Okay.
Anything else?
No. Thank you, Sean.
Yeah. Bye, guys.
Bye.